After seeing the code, let's solve these two problems using the segment tree. You know, the first problem is problem static range sum query from CSES online judge. This is the input. The inputs of the problem. We have n and q, the original array A, and the left and the right boundary of each query q. First, let's build the segment tree by computing the size of the segment tree. You know that the size is equal to 2. The size m, let's call it, is equal to 2 times 2 power k, which power the ceiling of log base 2 of n. Sorry, 2. Okay, 2 power k and minus 1. We're going to use in this first version of the code an array to build segment tree. And because we want the sum, we have to initialize the segment tree to all the nodes of the segment tree to 0. Okay. Let's delete here the pointer. Let's call the function build. That will use the array seg. Of course, to build that array, to build that tree, we need the original array A, the position, the start position of each node, the end position of each node, and the position of each node. The base case, as we have seen in the previous slides, we have to understand how to build the logic behind this function to be able to code it easily. Don't just see the code and copy paste, guys. You have to understand the logic to be efficient in coding. Okay, the base case is if S is equal to E, which means if we have a leaf, so the value of that node at that position is equal to the value at that of the array at that position. And we have to terminate the call here of the function build. After that, we have to call the function recovery to the left subtree and the right subtree. So we have to compute the middle array. Then we call that function. First call is for the left subtree, so which means from S to the middle, the position of the left subtree is at 2 times p plus 1. Same for the right subtree, plus 1 to the end of that node. Okay, and after terminated all the left side and the right side, we have just the leaves though. So now we can say that the segment, the value of the node of the position of the segment tree is equal to the minimum of the left subtree, to the sum, sorry, now the sum of the left subtree and the right subtree. Two times p plus 1 plus segment tree and the value of the right subtree p plus. Okay. Let's call the function here. We have to build segment tree array. The first position of the root is from 0. The first the interval of the root is from 0 to n minus 1. At position and the root is at position 0 in the segment tree. We have 5 parameters. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I think it's okay for our segment. Let's display it just to check if we are right or not. Just we're going to display the value of each node like this. We have an array, don't forget that. Okay, std. Let's try for this example. Voila. We have going on here. Maybe I have a mistake here. Let's display this. It's okay to make mistakes. You have to understand the logic, and maybe you made a mistake. You forget something here. It's okay. It's not the end of the world. This. Okay. I think we have a problem here. Red array new length. Okay, let's comment on this. Let's go on here. The length is -1. Okay, we have a mistake on the length here. Why -1? I think I have a mistake here. 2 power. Is that right? 2 power k. Can we write it like this? Sorry, I completely forget this. I think 2 power k. One. That is like this, 2 power k. Okay, this is why I want to make it like this, because it's constant time, this computation. Okay, let's remove the comments here and check what we have. Okay, I think this is okay. It's the sum from all of these is equal to 24. It's okay. Now let's build. Let's write the function RMQ. It will use the segment tree. And of course, the start position of the node, the end position of the node, and the left boundary, the right boundary, and the position of that node. First, we have to check if we have no overlap, which means the left is greater than the end, or the right is less than the start position. So we have to return what here? We have to return 0, because we want the sum. So any sum plus 0 is equal to 0. In the other case, if we have a total overlap, which means the left boundary is less or equal to the start, and the right is less. The right is greater or equal to the end position. We have to return that node, the value of that node. Otherwise, we have a partial overlap. We compute the middle. And we return what? We return what here? We return the RMQ of the course of that segment. Using segment tree, start position to the middle, the left RMQ of the left subtree. The left boundary and the right boundary remain the same, and the position of the left tree is 2 times p plus 1. Plus, because we want the sum, plus the right boundary is from the right subtree. Sorry, is from middle plus 1 to the end of that position of that node. 2p plus 2p. I think it's okay here. Let's try it. We're going to display the sum using the segment tree. Starting from the root, from 0 to -1. The left boundary is given is L, the right boundary is R, and the position of the root is 0. Let's make it like this. Okay. What is the build function? I delete the build function. I don't know how I delete it. Mistake. Okay. I think it's okay. Let's delete the display of the array. This okay. And this okay. It's the second test case. Let's submit it to the online judge. Okay, practice. Where is some query segment tree array? This one. This one. Okay. That's okay. Let's solve it using pointers. The same problem. We're going to solve the same problem using pointers. First, I have to define the structure of the node. Let's call it node. The value and to put a pointer to the left subtree and a pointer to the right subtree, because we have a binary tree here. Let's make constructor for that for the tree. The first constructor will take just one parameter, which is the value of the node. And this constructor, the left subtree will be here. We're going to use this constructor if we want to create a leaf. The second constructor will take the value of that node and the left subtree, and the left subtree, if we are sure that there is one, and the right subtree, of course, right one subtree, and here we'll take left, right. I assume, guys, that you know what I'm doing here, but you know that you know the this is a kind a little bit the OOP, oriented object programming. I think I assume that you have just a little idea how to code a class or a struct. Okay, I think for the node definition of the node is okay. Now let's create the build function. It will return a pointer to the root of the segment tree. Okay. The base case here is weird. If we have a leaf, we want to return a new node. We have to call the first constructor with the A of S or of E, because we have the same index here, E is equal to S. Otherwise, we go to the left subtree and the right subtree. Let's start by the left subtree. Okay, let's compute the middle first. Okay, and the right subtree. If we build the left subtree of each node and the right subtree of each node, we can at this moment we can compute the sum of the both left and right subtree of that node. The sum here, to be careful, is not the minimum, and of course we have to put here the left and the right for that node, its left and its right subtree. I think it's okay. It seems it makes sense. Now let's implement the function query or ArmaQ. It's not ArmaQ. I'm sorry for this. It's RSQ, because we want to range some queries, not minimum queries. Okay, same for the previous code. And we use the array here. Let's fix this. RSQ here, or let's call it query, and we end of this query here and here, and of course here and here. Okay, same here. We'll call it query. It will take a node or a pointer to the root of the subtree of the segment tree, sorry, and the interval of that node. Let's call it SE, and the left boundary, of course, and the right boundary. As usual, if we have no overlap, we can come back to the presentation and the previous part and see how it works to code or to compute how to compute the overlap, no overlap, or total overlap, or partial overlap. Okay, and right is let's start. So we have to return 0 at the moment. If we have a total overlap, okay, we return the value of that node. Otherwise, we have a partial overlap. So at the time we return the sum between the querying of the left subtree plus the result of the right subtree. And here, of course, we're going to display the result of the query function here from left to right. Okay, query, take the segment tree. I think I have to first call the function build that will build the segment tree. It will return a pointer to the segment tree, the root of segment tree. Here, and we have from 0 to n-1, which is the interval of it. Okay, and here for the querying, we have to give the parameters, the segment tree, and of the root, this interval of the root from 0 to n-1, and the left boundary and the right boundary. That's right. Okay, mistakes. Errors. We have errors here, which is few arguments. We have a few arguments here. We have the pointer and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4. I have a mistake here. Okay. Okay, this one is passed. This one is failed. This one. From 1 to 6. 1, 2, 3, 4, 5, 6. The sum of all of these is equal to 1. I think it's the same as the previous example. Okay. 21, 4, 25. Yeah. Okay, it's okay for this. 21, 4, 25. And here, I have 11 here. Twenty-one, 4, 25. Why I have 11 here in this? It's not the same expected output here. That's why. Okay. Okay. Let's try to paste it, to submit it. And all I judge. The same problem here. We're going to use segment tree, but use a pointer in the segment tree. Okay. Practice range SRQs queries segment tree pointers. You have your wrong answer. Here. I think, okay, have long here, okay, long here, here, long, must be long. I think this is the mistake. Where's the, okay, let's resubmit it. Here, this one. Okay. Practice some arrange some query segment tree pointers. Okay, as accepted. We're going to do the same for the problem range XOR queries. First, we're going to use, let's use just one. Let's use the pointer here because it's the same, and the only thing that will change is the operation, the input. Up here, okay, for this. In the function build, we're going to change this by the operator XOR, and here also XOR, and here when we have no overlap we have to return 0 because any number XOR 0 is equal to that number. I think it's okay. Just as you see, just we have to change the operator here in the build function and the query function, and this one return 0, why we have no overlap. If you remember, on the minimum range minimum query, we have to return the infinity. So here, when we have the case no overlap, you have to know what you have to return. It depends. It depends of the operation, the function that you use, the sum or the minimum, maximum, or the function. Let's try to sum it. This one. Right. Right, the folder here, this one, and this one. Practice XR pointers. Done it. Okay, it's accepted. You can, of course, you can implement the code using an array. It will remain the same. Just you have to change the operator. And the next part, we will try to resolve this problem from lead code. But here you can use, it's up to you to use what technique. We're going to use 2 or 3 techniques here, maybe segment trees or square root decomposition or any other technique that we have seen on this whole section. Try to do it by yourself, guys, and keep feedbacks in the comments.